Hello, pre-calculus kids. Today I'm going to start for us the last unit that we're going to cover for the rest of this school year. It's on the law of sines, the law of cosines, and finding area of triangles. And what makes this different from what you did previously is that these are now triangles that don't have to be right triangles. For everything we've been solving so far, it's been all the trig functions, all the sine, cosine, and such, and they all involve right triangles. So the question is, what happens if you don't have a right triangle and you need to figure out what the sides are or what the angles are? And that's what this unit's all about. It's kind of fun. It's all based on a lot of formulas. And I'm going to use the back of our mastery check to give you some background on what we're talking about. So first thing I want you to think about is you've got some kind of triangle that's not a right triangle. And I'm going to call my triangle A, B, and C. And we use capital letters to be able to represent the angles. And we use lowercase letters to represent their opposite sides. So if this is angle A, then little a would be the one that's opposite that. So this is little a over here. If this is angle B, opposite that would be over here. We use a lowercase b. And if this is angle C, then this one would be our lowercase c. So capital letters represent the angles and lowercase letters represent the sides. So that's one of the things that you're going to be looking at. In order to do this, here's what the law of sine says, and you're going to see the actual proof of this in the flip math video, but I'm going to give you the formulas because really this section is all based on formulas. And what it says is that the sine of angle A, this is the law of sines, over little a, its opposite side, is going to be proportional with the sine of angle B over its opposite side, little b, and it's also proportionate with the sine of angle C over its opposite side, little c. This, my friends, is what's called the law of sines. It's the formula for the law of sines. There's a different formula you're going to use for law of cosines, but this is the one that you want for law of sines, which is this whole first section of Unit 12. Now, you have three fractions here. What you're going to do is only use two when you set it up. So you could have the sine of A over little a equals the sine of C over little c. Or you could have any combination of these, but you're only going to use two fractions, not all three at the same time. But this law just says that all of these different sides and angles, the sines of those angles, are going to be proportional to one another. The other thing that we have to keep in mind that comes from geometry back in the day is that, let me just draw you a triangle and show you what I mean. If I still have this is angle A, this is angle B, this is angle C, let me toss some numbers in there just for fun. Say this is 30 degrees, say this is 70 degrees, and say this is 100 degrees. Oh, is that going to work? No, too big, too big. Yo, winner. Jane just got a 50, right? A triangle has to add up to 180 degrees. So one thing we want to remember is the angles of a triangle equal 180 degrees. That's how we're going to find some of these angles, is to subtract from 180. The other thing that I want you to remember from geometry is that the largest angle has its opposite side the largest. So this side, if it's the biggest angle, then the biggest side is going to be this guy here. If this is 50 degrees, see how that's the medium angle out of these three? That one's going to have, this one's going to be the medium size. Medium, if I can spell. This one is 30 degrees, so this one's going to be the smallest. So the smallest side is opposite the smallest angle, the biggest side is opposite the biggest angle. And that's something that you're going to need to remember in the midst of solving out these triangles. All right, so that's the background on the law of sines. Let me show you how it works. Oh, by the way, sometimes in your questions, you have three possibilities, yeah. You have one possibility when you go to solve this that you have no solutions. Sometimes you'll have a problem and you'll be able mathematically to know when that's going to be the case. And I'll show you examples of each of these in just a second. So you have one possibility that you could have no solution to the question. You have a second possibility that you could have one solution. They're the nicest ones. But you also have a third situation where you could have two solutions given the information that they show you. Now that gets a little more complicated because it's a little bit more work. So I'm going to show you examples of each of these situations as we do the mastery check. So let me flip us back over. You need your calculator and you need your calculator to be, let's check the mode. You want your calculator to be in degrees. So double check, make sure that that's the case, that you're in a degree mode when you're using the calculator or using the Google calculator or however you're getting your angles. All right, so here it goes. I like the picture, and this is solve the triangle, solve each triangle. In other words, they want you to find all of the angles and all of the sides. So for me, it's all based on a picture. Let me draw a picture up here because we don't have a whole lot of space. All of my pictures are going to be the same, A, B at the bottom, and C at the top. You can make them any way you want, but I'm just going to keep it standard for every triangle. So angle C is 55 degrees. And what I mean by that, making it just a standard triangle, obviously this is your obtuse angle in the way that I've drawn it, but based off the information they gave me, that's an acute angle. So I'm not going to worry about the picture necessarily jiving with the information they gave me. I'm just going to keep a standard triangle that goes A, B, and C at the top and go off of that. So yes, I know that I've drawn this as an obtuse angle, but I'm labeling it as an acute angle. It's okay. All right, I want to know, little b is 25. Well, angle b is here, so little b is across from it over here, 25. C is 9, little c. C up here is 55. That means that this guy here is going to be 9. And what you're looking for to set up your proportions, remember, and I'll put this at the top of the page over here too, the sine of a over little a equals the sine of b over little b equals the sine of c over little c, and I'm going to use 2 of those fractions. So in other words, I need to have one where I'm seeing an angle and the side opposite where I'm given both of those pieces. And so I can see for C I'm given that. I've got the angle is 55, the opposite side is 9. That's this fraction right here, and that's the first one I'm going to write. So I'm going to say the sine of 55 degrees, angle C, over little c, which is 9, equals. And then the only other piece of information, you have to have 3 pieces of the 4 in your proportion. You've got to have 3 pieces. So I have I have B is 25. That means I can find angle B. See how I have the opposites? I can't find A because I know nothing about A. I don't know the angle and I don't know the side. So the only thing I can solve for is B. So that's what I'm going to do. Sine of B over 25, little b 25. All right, so there's my proportion. Remember, you're using 2 of the 3 fractions, and that's what I have set up here. So I've got 2 of the 3 fractions. It's going to be like cross multiplying. So what I do is I go to the calculator and I figure out on the calculator what is the sine of 55. So let me clear this. I want the sine of 55. It gives me 0.819. Now you're going to round these to 2 or 3 decimal places, whatever makes sense in the problem. I'm going with 0.819. So here it is, 0.819. That's the sine of 55 over 9 equals the sine of b over 25. And what I'm going to do is cross multiply this thing. So I'm going to take 9 times the sine of b equals 0.819 times 25. So I'll take this number times 25. I get 20.48. So this gives me 20.48. Which means divide by 9 now. The sine of b equals whatever 20.48 divided by 9 is. And that would be 2.28. Somewhere around there. Now remember, you're rounding. So I want to know what that angle is. And if you remember back from our last unit, I would take the -1, sine to the -1 of 2.28, and that would give me what the angle is. So let's try it. Second sine of 2.28, and it says, whoa, there's an error there. And you're like, what do you mean there's an error there? But there is. This gives me error. This is one of those where it's a not possible. You can't have that happen. Sometimes you're going to have triangles that the measurements won't add up. The proportions of them won't make it be able to create an actual triangle. And this is one of those situations. The background behind this is, if you remember the sine graph, here it is. What's the tallest it goes to? You tell me 1. What's the lowest it goes to? You tell me -1. It's never going to hit 2.28 because that's too big. So this is one of those that's a not possible. And it just works out in the math that you end up knowing that you get an error and that you can't have a possible triangle out of that. All right, so there's one situation, situation number 1. I'm going to go to number 3 next, because I want to show you, number 2 is a little bit more difficult. So let's go to number 3 before we get too far into this. And I'm going to do the same thing. I'm going to draw myself a triangle. Here it is. Here's A, here's B, here's C. I'm keeping it standard, always going to be my triangle looking like that. My angle B is 29 degrees. My angle C is 104 degrees. And my little a, here's little a, is 6. And if you look at that, remember we're looking for a pair where we know the angle and we know the opposite side, because that's the only way we can set up this law of sines to work. So if I'm looking at this, they didn't give me that. They gave me one piece of information about C, one piece of information about B, and one piece of information about A. And you're like, whoa, now what am I supposed to do, right? So you're smart. You remember, how much should a triangle add up to? And so you say 180 degrees. So we're going to take 180 degrees. We're going to take away 104. Oh, not 5, 104. And we're going to take away 29. The two angles that are already existing in our triangle. That leaves me 47, and so that's what angle A would be. So although they didn't really directly tell me what that was, I know that that's going to be 47 degrees. And now I can set up a proportion because I know two things about A. I know the angle is 47, and I know the opposite side is 6. Equals. Now I have choices. I can either figure out little b first or little c first, and it does not matter which one you pick, but I'm going to go with b just because that's the alphabetical order. So I'm going to take the sine of b, which is 29. I can put that in there. Sine of 29, I know my angle. And I'm looking for little b, this guy here. So I go to the calculator and I figure out what these two things are, and I put the decimal points of them. So sine of 47 gives me 0.73, and since I'm here, the sine, not second, just regular old sine of 29, I get 0.48. Alright, so here's how I'm going to set this up. I said that this guy here was 0.73 over 6, and I said that this guy here was 0.48 over b. And so by cross multiplication, I can figure out what this actually is going to be. So I cross multiply 0.73b equals 6 times 0.48. I get 2.88. And then I divide. So when I divide that, my final answer comes out to be 3.98. And I've just figured out what little b is. So that's this guy here, 3.98. I can't use Pythagorean theorem to figure out the other side because remember this is not a right triangle and that only works for right triangles. So what I need to do is go back and do this again to set it up so that I can solve for C, little c that is. So I'm going to go back. I know all the things about A. There's a lot of choices here, by the way. You could just use the sine of 29 over your B of 3.98, but I tend to go back and do this because I've already done the work for it. So I'm going to set up a second set of fractions. The sine of 47 over 6 equals the sine of C, 104, over little c, so I can find C. I already did the work for this, so 0.73 over 6 equals, I do need to know what the sine of 104 is, and I get 0.97. So I'm going to put 0.97 in this slot over C. I'm going to do the same cross multiplication. So 0.97 times 6 divided by 0.73 gives me a C value of 7.97. And so I have now solved that triangle. I've got all the angles and all the sides. And this is an example where you have one possibility. So we have the situation where there's no possibilities. It wasn't possible at all. And this is a situation where I've only got one set of numbers that's going to work for this particular triangle. So let's go to 2. So number 2, if I do my same drawing, here's A, here's B, here's C. B is 71 degrees this time. Little a is 35 degrees, or 35, and little b is 34. Which one did they tell me two things about? A, B, or C? They told me two things about B. That's going to be your setup. The sine of B, which we know is 71. Put that in there. Save myself a step. sine of 71 over 34 equals, I only know something about a, so I'm going to go for finding little a. They didn't tell me anything about c, and so I'm going to have to save that for later. So I've got the sine of a over 35. So I go to my calculator and I say, all right, what is the sine of 71? And it tells me it is 0.95, we'll round it up, 0.95 over 34 equals the sine of a over 35. I'm going to cross multiply, so times that by 35, divide it by 34, gives me the sine of a equals 0.973, which means that the sine to the negative 1, because I'm looking for the angle, of 0.973 equals, second sine, 0.973, 76.7. 76.7 degrees. Alright, so here's where it gets a little complicated, because actually, to be honest with you, this one is going to have two solutions to it. Here's where they come from. Do you remember back when we were doing stuff with the right triangles, and these, what we're coming up with here when we get this, is actually a reference angle. And there's two places where the sine is positive. It's a positive 0.973. There's two places that can happen. It can happen in the first quadrant, and it can happen in the second quadrant. It's the reference angle that you're coming up with here. So if it is, remember all students take calculus, so in the first quadrant everybody's positive, in the second quadrant sine is positive as well in the second quadrant. So first quadrant it always is whatever the reference angle is, but in the second quadrant it's 180 minus that reference angle. Okay, so if I take my calculator and I 180 minus 76.7, I get 103.3 degrees. So think about what you already have in your triangle. You already have a 71 degree angle. Could it be that this other angle, angle A, is 76.7? Would that leave us enough for a third angle? And if you just roughly think about it, that's probably about 147 degrees. Yeah, there's stuff left, right? There's room left. If I put 103 degrees with this, I have 103 would give me 174 degrees. Is there enough left for a third angle? And there is. It might be small, but there's enough there. So what happens with this is it could be 76.7 or it could be 103.3 because there's still room left for a third angle in the triangle. So what we have to do is there's two cases. So I'm going to come down here into this space. Let me go this way. All right, so case number one could be, that angle A is 76.7 degrees. And case number two could be that angle A is 103.3 degrees. It could be one of those two situations. I don't know which one works. So what you're going to do is then figure out what angle C is for each of these. Now if I have a triangle and my triangle has to add up to 180 degrees, let's see what we got here. I'm going to clear this. I have 180, I have 71 already in my triangle, and I'm guessing that angle A is 76.7. So I take those values and I subtract them away. That leaves me angle C in this case is 32.3 degrees. Now let me finish out this case number one. The only thing I have left to find, I have what little a is, I have what little b is, but I need to know what little c is. So little c, I'm going to set up my proportion. I'm going to go back up here. Remember I used the sine of b, 71 degrees, over little b, 34, equals the sine of c. In my case I'm saying it's 32.3 degrees over little c, and that's going to help me find that. All right, we know the sine of 71 is 0.95. We don't have to redo that work. I don't know the sine of 32.3. 0.534 over little c. I'm going to take this thing and I am going to cross multiply it. So I'm going to take 35 times 0.534 divided by 0.95, and that gives me a c value of 19.1. So In case number 1, I would have angle A, 76.7, angle C, 32.3, and little c being 19.1. If it was case 2, then I'm going to go back, I'm going to take 180 degrees, take away the 71 that was originally in it, take away the 103.3, that leaves me 5.7 degrees. Not very big, but possible for angle C. And I'm going to do exactly the same work I did here. I'm going to set it up, except this number is now 5.7 degrees. So I'll have the sine of 71 over 34 equals the sine of 5.7 degrees over C, because I'm trying to find what little c is. So I have this information, 0.95 over 34. I don't know sine of 5.7. I'm going to look that up right here. 0.099. All right, we'll use 0.099 over little c. I'm going to cross multiply times 34 divided by 0.95, and that gives me a c value of 3.6. Now, does that make sense? I kind of talked about this in the very beginning. Do you have the biggest side, or biggest angle opposite the biggest side? So if A is 103.3, yep, 35 is the biggest. Little c is 5, or angle C is 5.7, little c is 3.6, that's the smallest. It makes sense. It should make sense in your triangle when you're all said and done. All right, 2 more to try. So now you got the 3 possibilities. It's either not possible, it's got 1 situation, or it's got 2 situations and you need to do them out separately. Okay, number 4. I'm going to draw my triangle again. ABC. C is 34 degrees, little b is 21, little c is 20. What did they tell me 2 things about? Letter A, letter B, letter C. They told me 2 things about C, and so that's the one I'm going to do. So I have the sine of C, 34 degrees, over little c of 20. They told me 1 thing about B, which means I can find angle B. So sine of capital B over 21. I go to the calculator, I figure out the sine of 34. 0.56. So this will be 0.56 over 20 equals the sine of B over 21. So I'm going to cross multiply 0.56 times 21 divided by 20, and that tells me what the sine of B actually equals, and that would be 0.587. But then I need to know what the angle is. So sine to the -1 of 0.587 equals, gives me the reference angle, and that's going to be 36 degrees. Now let me look at this with you on the calculator. If I do second sine of 0.587, see how this one comes out to 35.944. It's really close to 36. Those you can round to the nearest whole number. But if it came out to be 35.2, you would not round that. You just would keep it as 35.2. But this one, because it's so close, we're going to call it 36. That's the reference angle. It can be in the first quadrant or the second quadrant. Let's figure that out. In the first quadrant, it is 36, the same as the reference angle. And in the second quadrant, I'm going to subtract that from 180. And that, subtract that from 180. It gives me 144 degrees. 180 minus 36 is 144. Is there still room for a third angle? 34 plus 36, well that's 70. Sure, there's room for a third angle. 144 plus 34 is 178. Believe it or not, it leaves 2 degrees for that last angle, so you have 2 cases again. This is a case 1, case 2 deal. All right, case 1. It could be that angle B is 36 degrees. It could be, case 2, that angle B is 144 degrees. If I figure out angle C based off of that, 180 minus 34 minus 36 gives me 110. Angle C here. 180 minus 144 minus 34 leaves me 2. There's my 2 cases. It could be one of those 2 things. Now I have to figure out little c based on these two pieces of information. So if I go back to the very beginning, use my beginning fraction, the sine of 34 over 20 equals, I'm looking for little c, so the sine of 110 over little c. So I go to the calculator. I already know that this is 0.56. Don't recreate the wheel. Sine of 110, go to your calculator. You get 0.94 over little c. Cross multiply. 0.94 times 20 divided by 0.56. And you end up, I'm sorry, I should be using the a's, right? Oh, this was angle A. I knew what c was. Let me fix myself. This is an A. A. Doesn't change any of our work, guys. Here's A. Here's A. Here's A. It was A that I was looking for, that missing side. So, one more time. If I take 20 times 0.94 and I divide it by 0.56, it's going to tell me little a, and little a comes out to be 33. Can I squeeze that on and you can see it? 33.6. Same thing here. Angle A would be 2 degrees. Set it up exactly the same way. Sine of 34 over 20 equals the sine of 2 degrees over A. We know that this is 0.56. The sine of 2 degrees, go to your calculator, it's 0.035. Cross multiply, 20 times 0.035 divided by 0.56 leaves you a little a of 1.2. And you've just solved that triangle with both situations. Alright, so last one. Now they changed the letters on you. What do you care, right? You can call it whatever you want to call it. But if I look at this one, STR, I tend to go in alphabetical order. That makes this R, this S, this T. Does it matter? Absolutely not. Just set up a triangle with those letters. Angle S is 72. Little r is 24. Little s is 16. And so you look for the pair where you've got the same letters, the side and the angle represented, and that would be with S. And so if I look at S, that's going to set my fraction up here. So sine of 72S over little s, 16. I only know one thing about r. That means I've got r left to find. Sine of r over 24. And so I go to my calculator and I figure out, all right, well, what's the sine of 72? I get 0.95 over 16 equals the sine of r over 24. I take 0.95 times 24 divided by 16. Tells me the sine of r is 1.4. And so you go second r, you want to know what the reference angle is, second r, 1.4. It says error. And you say to yourself, does that make sense? And the answer is, yeah, actually it does make sense, because remember, the highest that the graph can go to is 1. They want you to go to 1.4. You can't get there. So this is one of those that would be a not possible. Okay. That takes care of the introduction to 12.1. You're going to watch the flip math video on this, and they get really in detail about how you can tell just from the numbers they give you whether the triangle exists or doesn't exist. I'm not too worried about that, because really the math tells you whether they exist or they don't exist and how many solutions you're going to have. So if it makes sense to you, great. If it doesn't make sense to you about how many triangles you get out of it or how many answers you're going to have, don't worry about it. Just do the math. The math is going to tell you you've got no solution, you've got 2 solutions, you've got 1 solution, whatever it's going to be. So I go with the math of it rather than really the theory behind is it going to work or not work. So if you get something out of it, that's awesome, but if you don't get too teed up about it. All right, that's the law of sines. Next thing you'll have from me are some practice examples, doing some of the work for those. So give me a shout if you have any questions, and otherwise I hope you're all doing well, and I miss you. Bye.